Now, I did want to insert one comment here because there's one point that I often get questions on. I think it's important really to clarify these questions right from the beginning because I don't want to say anything that might be a little bit confusing. There's one thing that often gets us concerned is that if I look at the Coulomb's law I'm familiar with, right, F2 here, up here, it goes like 1 over the distance squared between the two different charges. And that makes sense, right? It's an inverse square force. We're all familiar with that. But if you look at the Cartesian form, notice I've got this distance now cubed in the denominator. And that sometimes freaks people out. And at first you can say, yeah, wait a minute, that doesn't look quite right. But there's something very important to remember. There's an important difference here in these two formulas here. I want to scroll down just a little so we can really kind of see what's going on here. The issue is that in the trig form, I'm multiplying here by a unit vector, right? This is length 1. This doesn't affect the magnitude of the force at all. It's just a direction. But when I go to the Cartesian form, the vector that I have is a displacement vector. It's this distance from R1 to R2. So I actually have an extra factor of distance, right, in the numerator. I've got an extra thing that has units of meters here up in the numerator. And it's because I've got extra distances in this numerator that I actually have to divide by one more factor of distance down there in the denominator. So then with this, then I think we're pretty much lined up and ready now to start with some examples.